We live inside a universe that is expanding, but the first question is older than expansion. Where did it begin?
Astronomy shows space itself is growing, carrying galaxies away from each other.
This is not motion through space. It is space changing shape.
And we see a relic, ancient light from when the universe was young.
Those faint ripples are the seeds of everything. Galaxies, stars, and us. The Big Bang model fits 3 pillars: expansion, relic radiation, and the chemistry of the early universe.
But the model has a locked door. It describes the early universe, not what came before. So today we open 5 origin theories. Hard science at the edge of mystery. Some are well-supported frameworks. Some are bold possibilities. We begin with the standard story, the Big Bang.
The Big Bang is not an explosion in space. It is space expanding from a hotter, denser state.
Galaxies separate because the grid grows, not because everything flies outward from a center. Early on, the universe was a plasma fog. When atoms formed, light finally traveled freely. That ancient light still surrounds us, cooled by expansion.
In the first minutes, the universe forged its simplest elements, mostly hydrogen and helium.
Then gravity amplified tiny ripples into structure. The universe became a cosmic web, filaments and voids. But if we rewind far enough, our equations hit a wall. The singularity is not a place we can confidently describe. It is a sign our physics is incomplete.
We have 2 powerful theories, gravity and quantum physics, but they disagree at the beginning.
So the true origin problem is a theory problem. The Big Bang describes the early expansion well.
Yet it leaves puzzles. Why is the universe so uniform? And why does it look so flat?
Those puzzles are the gateway to inflation. Inflation is a hypothesis of a brief, ultra-fast growth spurt in the early universe. Now we open inflation and what it predicts.
Inflation can explain uniformity by stretching a once-connected region to cosmic size.
It can also explain flatness. Rapid expansion drives curvature toward nearly zero.
Inflation turns quantum jitters into large-scale ripples, seeds for galaxies.
That means the CMB is a fossil record of quantum noise. Inflation predicts a specific pattern of ripples across scales. Some versions predict primordial gravitational waves, leaving subtle polarization patterns. So inflation is testable, but the tests are extremely hard. Inflation often uses a field rolling down an energy landscape.
But we don't yet know the exact field or the exact shape of the landscape.
Some critics argue inflation can be too flexible, fitting many outcomes. The deepest question is whether inflation truly predicts, or mostly explains, after the fact. Still, Inflation remains our best framework for the early universe's smoothness and seeds.
But inflation opens a bigger mystery. What if inflation never fully ends?
Eternal inflation suggests universes could form like bubbles in a boiling field.
Those bubbles could have different physical details.
That leads toward the multiverse idea. Powerful, but hard to confirm.
There is another family of ideas. The universe may have bounced.
Welcome to Big Bounce and Cyclic models. In bounce models, the universe had a prior phase, often a contraction.
Quantum gravity effects might prevent a singularity, replacing it with a bounce.
If so, our universe could inherit structure from a previous epoch.
The key question is, what survives the bounce? Some models propose repeated cycles, like cosmic seasons. But cycles face a thermodynamic problem. Entropy tends to increase. Cyclic models must explain how each cycle stays viable. These models seek observational signatures in the CMB and large-scale structure. But anomalies are tricky. They can be noise, or hints, or wishful thinking. Bounce models are motivated, but still unconfirmed. Now we step into higher dimensional origin ideas.
In Braneworld models, our universe could be a surface in a higher dimensional space.
A Big Bang could be a brain collision, an event in a higher dimension.
Such models can change how gravity behaves at extreme scales.
We are constrained by experiments, but direct evidence is still missing.
Braneworld ideas are elegant, but remain speculative.
Now the most controversial door, the multiverse.
One motivation is the puzzle of constants. Why do they allow complex structure? The anthropic idea says, we observe a habitable universe because we are here to observe it. But this can feel like explanation without predictive power.
Some propose possible evidence, scars from bubble collisions in the CMB.
So far, nothing definitive has been found.
There is also a deep mathematical problem, defining probabilities in an infinite multiverse.
This is where physics touches philosophy, not as a weakness, but as a boundary.
The multiverse remains a possibility, but evidence is elusive. So where does that leave us? With a map of possibilities. Some ideas are strongly supported. Others are educated speculation.
Science pushes the blur backward by building better measurements.
The origin story is not one theory. It is an ecosystem of tests. The final missing piece is quantum gravity, a theory of space-time itself.
Because the beginning and black holes may be the same kind of puzzle.
We have read some pages of the universe, not the first chapter.
And the universe keeps two secrets: what started it and what ends it.
We will open endings next time. For now, we close the origin file.
Truth is not one origin story. It is a set of constraints the universe allows. Cosmology is humility made scientific.
Because every hypothesis is an attempt to explain why anything exists at all. And meaning is what we build inside uncertainty.
From quantum ripples to galaxies, the universe is a chain of amplifications.
You are a local pattern inside a cosmic pattern.
We do not have final answers. We have sharper questions.
And that is what makes this science. It can be wrong, and it can improve.
The universe may have begun once, or many times, or in cycles.
We open the locks halfway, but the doors remain mysterious.
Origin is not a date. It is a boundary of knowledge.
And beyond that boundary, we do not know.
But that is enough. Science moves forward by lighting the next 3 meters.
To understand the universe is not to reduce it. It is to see it more clearly.
The unknown is not failure. It is fuel.
If you want more cosmic science with a touch of mystery, leave a like for Arcane Knowledge.
And subscribe. Next time we'll open the second case file, How the Universe Might End.